Hello and welcome to this concluding module of the UN Habitat Masterclass on sanitation and wastewater management. My name is Abhishek Narayan and I'm from the Department of SANDEC at the Swiss Federal Institute of Aquatic Sciences and Technologies. This module is all about the future of sanitation service delivery. We will highlight emerging innovations in the sector and the way forward to address the current sanitation challenges. We begin by introducing the resource recovery potential from wastewater and sanitation at large, and how innovations offer significant potential for circular economy, climate resilience, improved treatment, and public health monitoring. We will then conclude with 6 priority actions for governments, city planners, and development partners, and 2 enabling factors to support action, which will ultimately help us move towards sustainable urban sanitation for all. This is an exciting time for wastewater management. Wastewater is undergoing a paradigm shift and is increasingly viewed as a resource rather than a waste. Innovations focus on recycling and resource recovery, unlocking economic potential while addressing the global water crisis and climate change. Circular economy in sanitation and wastewater is primarily about water, energy, and nutrients. First, treated wastewater offers both potable and non-potable reuse options. Non-potable uses include irrigation, cooling, and construction. Advances in treatment technologies have also made potable water reuse possible. To manage health risks for safe reuse, there is a need for robust and fit-for-purpose standards and regulations. Second, biogas and biosolids from fecal sludge could be used for energy generation. We could also recover the waste heat from wastewater for domestic and industrial heating. By tapping into these, we can reduce emissions and generate additional revenue through carbon credits. Third, wastewater is full of phosphorus and nitrogen. These nutrients can be recovered for use in agriculture as fertilizers. We could, for example, meet 30% of global nitrogen fertilizer demand from wastewater. Overall, these practices not only support our efforts towards creating a circular economy in sanitation, but also enhance climate change adaptation and mitigation. Many wastewater managers perceive climate change as a distant threat. This is reflected in the allocation of only 3% of water-related climate funds to sanitation in 2017. However, climate change increasingly impacts sanitation services, with droughts, floods, storms, and rising sea levels, damaging infrastructure, disrupting services, and thereby creating health risks. Anticipated extreme weather is likely to set back achievements in the absence of a strong public policy response. To address these challenges, planners and authorities must adopt climate-resilient sanitation approaches. A resilient system is robust, flexible, and integrated. They could follow a blue, green, gray infrastructure approach that includes water-sensitive urban design and integrated flood control and decentralized solutions. So-called sponge city strategies effectively support managing runoff and recharging groundwater through low-cost nature-based solutions. There are several advancements in treatment technologies as well. While low-cost nature-based solutions can play a vital role, urbanization introduces new pollutants into wastewater that these often cannot effectively treat. Emerging contaminants such as pesticides, pharmaceuticals, and microplastics necessitate advanced treatment solutions. As a result, we also have emerging technologies such as membranes, microalgae, microbial fuel cells, and ultraviolet radiation-based treatment. While these are increasingly popular solutions, depending on the treatment technology, various challenges such as high costs, high energy requirements, short lifespans, and land use challenges persist. Another innovation is wastewater-based epidemiology, which gained momentum during the COVID-19 pandemic. Wastewater-based epidemiology analyzes wastewater to monitor microbial and chemical exposures concerning public health in real time. This offers a cost-effective alternative to clinical testing. Its effectiveness, however, depends heavily on the sanitation infrastructure. Centralized sewer-based systems allow easier implementation, while areas reliant on on-site sanitation provide challenges for this approach. Throughout this masterclass, we highlighted global sanitation challenges and introduced promising examples based on a global mapping exercise and research from 18 cities. Overall, the global mapping highlights that wastewater and fecal sludge management remain on the fringe of urban development. Therefore, a strong and urgent public response to the urban sanitation challenge is needed. The pace of urbanization worldwide is not only a huge driver of economic growth and opportunity, but also a potential vector of environmental and human health degradation. This is because sanitation systems in many countries are inadequate, from wastewater and fecal sludge collection to treatment services. This is reflected in 1.9 billion people, which is about 25% globally, using inadequate toilets, and 3.6 billion people, which is up nearly 50%, who are not using safely managed sanitation systems. The necessary public response to urban sanitation challenge must include appropriate accountability mechanisms, clear roles and responsibilities, as well as adequate resource planning and management. Data management and digitization are essential to drive these improvements. Finally, we have shown how emerging innovations offer significant potential for circular economy, improved treatment, health and monitoring, and creating climate-resilient systems. Now, how can governments, city planners, and development partners move forward in practice? Here are 6 key action areas that align with a public service approach to sanitation. Number 1, cities need to invest more across the entire sanitation service chain and invest more smartly, with specific attention to the environmental context as well as socioeconomic conditions and climate risks. Number 2, wastewater and fecal sludge management services must be integrated with national and local urban policies, strategies, plans, including slum upgrading processes. Number 3, roles and responsibilities with regards to sanitation, service delivery, policy making, etc., have to be clarified so that actors have clear mandates to deliver on. Number 4, financial and human resources must be allocated to regulation design and enforcement, without which service providers will not have incentives to invest as they should. Number 5, national monitoring systems for sanitation must improve radically, with countries supported in developing credible public data systems, incorporating all sanitation outcomes. Number 6, cities need to adopt measures for safe wastewater and fecal sludge valorization, even ahead of the full development of sanitation services, to mitigate health and environmental risks associated with this service. 2 cross-cutting enabling factors for these actions are: funding for research needs to continue and possibly increase to support the development of technologies and service models adopted to different contexts. Peer-to-peer learning and South-South cooperation must be supported to share knowledge and inspire replication of best fit approaches. By applying these global lessons in sanitation and wastewater management, we can significantly enhance the living conditions and improve the quality of life in cities across the world. Thank you.